Question number 4 on our tree diagrams assignment. A friend wants to visit 4 different cities. In class, remember I told you interpreting the question is very important. You want to see this. A friend wants to visit 4 different cities. That means they can't visit the same city twice. 4 different cities, we're going to label them city A, B, C, and D, but only has time to visit 2 of them. So they can only visit 2 of the cities because of time. What are the possible outcomes? Well, think about this. If you think about the question, a friend wants to visit 4 different cities but can only visit 2 of them, then our tree diagram is going to map out the cities and see how many combinations are possible. So here we're starting on our tree diagram. The friend has visited none. The first time they go to a city, they've got 4 options: A, B, C, and D. We're going to call that our first branch is going to be city number 1. That's the first city they can visit. Now if you notice on this tree diagram, when I go down to the next level, when we're looking at city number 2, there's only 3 branches, but there were 4 cities. So this is an example of where, as I was drawing the tree diagram class, I noticed that if they already visit city A, they can't visit it again because it says the friend wants to visit 4 different cities. So once they selected city A as their first city, A can't show up here anymore. So the only cities possible as the second choice are B, C, and D. And for branch B, the only possible choices are A, C, and D. And branch C, A, B, and D. And branch D, A, B, and C. Now, when you draw this tree diagram, or if you drew it on a test, you could draw the 4th branch down here and have A. The thing is, that's going to end up with a probability of 0. So the total probability of visiting A and A again is going to be 0 because you can't visit the same city twice. So in this case, I saved a little bit of time by just dropping that branch off because city A is not going to be visited a second time. Alright, let's take a look at our probabilities. 4 choices, probability of picking city A, 1 city makes us happy, A, over total number of cities, 4. So 1 out of 4 is our probability. Same thing for B, same thing for C, and same thing for D. We have 1 out of 4 chance of picking that city. Now in the next level, that first city is now gone. So you can see this is no longer independent. These are dependent events. The second city is influenced by the first city because you're not allowed to visit the same city twice. So now B is the 1 city that makes us happy out of 3 total cities. So on this level, we're going to have 1 city makes us happy on this branch over 3 total cities. Same thing for C. And in fact, now just start writing, class, because every branch here, A is 1 city out of 3 choices, C is 1 city out of 3 choices, and so on. So every branch is going to have a 1 in 3 chance of being selected because the 1 represents the outcome that made us happy on that branch. The 3 represents the total number of cities you could select from. Alright, well, our tree diagram is finished. We had city number 1 picked and city number 2 picked. Now let's multiply down our branches. 1/4 times 1/3 is 1/12. 1/4 times 1/3 is 1/12. In fact, even though the second city is dependent on the first city, it ends up being the exact same probabilities, and the reason why is because we dropped out A. Now this is 1 out of 12. One out of 12. Every one of them is 1 out of 12 is our probability. Okay, so 1/12. Alright, so we got our probabilities across the bottom. Let's go ahead and add them up and see if they add up correctly. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 over 12. So our probability tree looks good. So now we can go ahead and begin to figure out probabilities. Alright. Letter A, if the two cities are chosen at random, what is the probability your friend will visit city B? Will visit city B. So the thing that makes me happy is visiting city B. So I'm going to find every branch where B shows up. So, first branch, A, B, that one's good. They visited city B there. AC, nope. AD, nope. Oh, all three of these branches are going to match, class. BA, BC, BD, we visit city B in every one of those branches. Okay, let's take a look at the third layer, the third branch here. CA, no good. CB, that one's good. CD, no good. And then DA, no good. DB, that one's good. And DC, no good. So we'll add these up. Probability of visiting city B is 1/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12, which is equal to 6 over 12, which is 0.500, and that's 50%. We've got a 50% chance if you picked two random cities, at least one of those cities would be city number B, city letter B. Next question, if the two cities are chosen at random, what is the probability that your friend will visit city A or city C? A or C. That means either A or C will make me happy. I got to find every branch, class, that has either city A in it or city C in it. So let's take a look. AB, that makes me happy because I visited city A. AC, I visited actually both of them. They make me really happy. AD, that also makes me happy. So the first branch, we can grab all of the branches, all of the final probabilities. 1/12 plus 1/12 plus 1/12. Take a look at the next branch. BA, that makes me happy because they visited city A. BC, that makes me happy because they visited city C. BD, no good. A and C are not, A or C are not in that branch. CA, that one makes me real happy. They visited both cities. CB, we're good. They visited city C. CD, we're good. Visited city C again. Last one, DA, yep, they visited city A. Looks good. DB, no good. DC, yep, we are good. So now you see what happens with the actual or in the question. Now we're finding branches that either visited city A or city C, or of course, class, both of them also make us happy because all I care about is getting an A or getting a C. Let's add these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means our probability of visiting city A or C is 10 over 12. 10 over 12. Actually don't have that calculated. Let's go ahead and do 10 divided by 12. 10 divided by 12 equals 0.8333. So this is 0.833, which is 83.3%. Pretty high probability that if you selected two random cities, you're going to be visiting either city A or city C. So there is the last question on your tree diagram homework.